In this video, we're going to talk about how do you write transformations in function notation. So in the objective 2, in the second objective, all you're doing is you're going to get this verbal description of a transformation. Like f of x was shifted right 4, up 2, and reflected across the x-axis. And you're going to have to write in function notation what that transformation is. So let's start with vertical transformations. So a way that you can transform a graph vertically, let's start with the easiest one, up or down. If I move, and let's start with, so f of x, that's just our starting point. We've got a function, and we're doing this in function notation, so we actually don't have like x squared or x cubed. It's just the generic function notation, f of x. If I want to move that function up or down, on the outside, I'm going to add or subtract something to it. Now, if that number is positive or greater than 0, it's going to move up that number of units. If that number is less than 0, say -2 or -3, it's going to move down that many units. So that's one type of vertical transformation we could have. Another type is a reflection. And it's the reflection across the x-axis. Now, if you don't remember or you get confused on whether reflecting over the x-axis is vertical or reflecting across the y-axis is vertical, just draw a picture, draw a point. I always like to use quadrant 1, or the top right quadrant. And if I reflect across the x-axis, that takes me down here. So yep, that is a vertical change. Reflecting across the x-axis, that changes the sign. So the y's were positive up here, they change to negative down there. So that puts a negative in front of the function. Then, let me take this away. Then if I want to do a dilation or a stretch, compression, that's where you're multiplying the function or the y values by something. So I don't know why, but they use the letter A for this, just like I don't know why, but they use the letter K when they talk about transforming up or down. So if A, and we talked about this in a previous video about dilations and how that works, but if A is greater than 1, it's going to be a stretch of that number. If it's a number between 0 and 1, in other words, fractions, it's going to be a compression of that number. So let me do some examples of vertical transformations. So if you see in a verbal description that we want to write in function notation a function that shifted up 5, we would just write this, f of x plus 5. If we wanted to write a function that had a vertical stretch of factor 2, we would write 2 in front, f of x, or 2 times f of x. Now if I wanted to do a reflection across the x-axis, it's just going to be negative f of x every time. Now I can combine these and do a couple of transformations in one. So say for example, I want to do a vertical compression of 1/2 and move the function up 1. Then it would look like that. So let's talk about horizontal transformations. Horizontal transformations can get tricky. What I want you to remember, the word, whenever you think of horizontal, I want you to think liar. Because when we write it in function notation, it actually doesn't do, or we don't write it the way we would think. So let's start with the simple type of horizontal transformation, and that's left or right. When I do a horizontal transformation, it's going to go inside the parentheses. So the letter that we like to use for this is H. H for horizontal. That's really the only one that makes sense of these letters that we use. Now if H, this is where it gets tricky. If H is positive or greater than 0, that's actually left H units. It lies. You think if you add a positive number, it would mean go to the right. That's just what your normal brain would think. But it doesn't. It goes to the left. Negative numbers goes to the right. Now you learned this in Algebra 1, but I know it's been forever. And I could explain why it does the opposite, but that might be a little bit more detail than you're interested in right now. So you just need to know horizontal transformations, they lie. Okay, now let's do the type of horizontal reflection is a reflection across or over the y-axis. That goes inside the parentheses as well. When you do reflection across the y-axis, say I start here, x's are positive on this side, negative on the opposite side. So you're changing the sign of your x. Then horizontal stretches and compressions. This is probably of all the different types of transformations, this is the most complicated and the easiest one to miss. So if I want to do a stretch or compression, it's going to go inside the parentheses, and I'm going to use the letter B for that. Now, if B is a value greater than 1, so like 2 or 3, so if I had this, you would expect that that's going to be a horizontal stretch, because that's what it would be vertically if I had the 2 out in front. But horizontals lie, and so it's actually not a stretch, it's a compression. And when we use the word compression, like compression of factor blank, what number, we don't use a whole number or a number greater than 1 for compressions. That we use for stretches. So this gets tricky. I have to take that number, so if it was, say, my example, f of 2x, I would say that this is a horizontal compression of factor 1/2, not of 2. And then if my value is between 0 and 1, that's actually a stretch. And it's still a stretch of 1 over b. Because if I do a stretch, let's say I put 1/2 here, I would say this is a horizontal stretch of 2, not 1/2. Because if we use the word stretch, we want this number to be bigger than 1. You probably might have to rewind and listen to and watch this part of the video a couple of times to get it. But like I said, this is the piece that many students have trouble with. And I've been teaching Algebra 1 and Algebra 2 for quite some time. So when I say that a lot of students struggle, I really mean it. So if this was hard for you to grasp, you're certainly not alone in that. So to recap, horizontals, they lie, and they go inside parentheses. If they're vertical transformations, they go outside. So let's do a couple examples. Let's say we want to write a function that we moved right 2, up 1. Let's just do that, right 2 and up 1. In function notation, right is a horizontal, so it's going to lie and it's going to go inside the parentheses. So it's not plus 2, but minus 2, x minus 2. And then up 1, that's a vertical. It does it exactly as we would think, and it goes outside, so plus 1. That's my function notation. Okay, let's do another one. Let's say I want to write a function in function notation that we do a vertical stretch of 3 and down 2. So vertical stretch of 3, that's a vertical transformation, and when we do stretch or compression, that goes out in front. Down 2 is also vertical, so that also goes outside and it tells the truth. So it's not plus 2, but minus 2. So that would be that one. Let's do some with some reflections. Let's say I reflect across the x-axis. I do a horizontal compression of 1/3 and down 5. Say those are the 3 transformations I want to do. Well, reflection across the x-axis, remember that's a vertical transformation, so that goes out in front. Horizontal compression of 3, horizontal, so it's going to go inside and it's going to lie. So compression of 1/3, we actually flip that over and turn that into 3. And then down 5, minus 5. Let's do one more. Let's do reflect across the y-axis. Vertical compression of 1/4. Let's just do those two. So reflection across the y-axis, that's going to make the x negative inside. Vertical compression, 1/4, that goes out in front. And that would be my answer. What if I flip it around? What if I give you something like this? And I asked, what are the transformations that are shown? Well, the negative in front, that's a reflection across the x-axis. The 1/2 is a vertical compression of factor 1/2 plus 2. Oop, need a different color. Inside the parentheses, that means horizontal. Horizontal, when I add or subtract, that's moving left or right. Plus 2, you would think that means right 2, but remember it lies, so it's left 2. And then last, the minus 1 here, that's vertical, down 1. Okay, so in this objective, you're just using function notation and identifying transformations either from a verbal description or from something that's already written in function notation, and you're identifying which transformations they wrote. So hopefully this will help you with objective 2.